I'm Larry Hawkins with Analog Devices, and today we're going to talk a little bit about some tools for simulation, both signal chains and PLL performance. If you would like to join us, that would be great. The agenda, what we're going to do today is I'm going to introduce a program called ADI Sim PLL and ADI Sim RF. These are two programs that are used to be able to simulate both signal chains and also to be able to simulate the different performance parameters for PLLs. Along with that, I'm going to introduce some changes to the versions. These programs have been around for a little while, and I'm going to demo both programs to you. But to start with, Analog Devices is a very broad line RF semiconductor company. A lot of people think of Analog Devices as converters, both ADCs and DACs. But actually, Analog Devices is one of the broadest line RF semiconductor companies in the world. We cover all of these signal chains, whether it's LNAs, amplifiers, modulators, demodulators, mixers, PLLs. We have the full signal chain, and that helps with these simulation tools and to be able to put together a full system for you. This gives you an idea of some of the fractional end PLLs that we have. They would use external VCOs. As you can see, that we have quite a wide range of PLLs. We also make PLLs with integrated VCOs. As a matter of fact, we introduced two of those today, both the ADF 4355-2 and the ADF 5355. We've introduced at this show. One of them being a next generation part, the other one being a much higher frequency version of our previous series of integrated PLLs with VCOs. Along with that, this just gives you an idea of a smattering of maybe some of the mixers that we have. This is our portfolio of some of our mixers that we have currently. As you can see, we have a broad range of mixers, and we have equally broad range of all the other components in the RF signal chain. So ADI has all of the pieces, but the question you have to ask yourself is, how do I make sure that I have the best part for my system? And that's a question that you have to have. And so what Analog Devices has done is they've came up with a group of programs. One of those programs is ADI Sim PLL. ADI Sim PLL is a comprehensive, easy to use PLL synthesizer design simulation tools. What you can do with it is we enable you to be able to get the performance on all the nonlinear effects that can impact PLL performance, including phase noise, fractional end spurs, anti-backlash pulse, all of those key parameters that you do when you're designing a system using a PLL. We make those, we allow you to simulate those very accurately using the program ADI Sim PLL. Another program that is actually more recent, we introduced this program a couple of years ago. It's called ADI Sim RF. And what this is, it's a signal chain calculator. It allows you to be able to simulate cascaded gain, noise figure, IP3, total power consumption. It includes modulators, everything from modulators, demodulators, mixers, but even more different than what's available on the market for these type of simulators. We allow you to be able to simulate using ADCs, DACs, ADC drivers, and we do all of the impedance changes and so forth that can make your life a lot easier by using a program like this, something that's a little bit more difficult to be able to do using a spreadsheet type application. So this is designed to be able to save you time. In the ADI Sim RF, our new version of that we've introduced at the show, we've included all of our new devices. We've also included some new features like a charting function, dynamic range calculator, max stage count was increased from 15 to 20, as well as other things we've introduced with this program. And I will demo that for you. With that, I thought I would just get right into ADI Sim PLL. This is a very easy to use program. It's a program that is able to, as I said before, is able to simulate all the nonlinearities that come with doing PLL type simulations. The part is very easy to pull up. It's very fast. This is again ADI Sim PLL. And again, you have a tutorial that you can choose from, but I'm going to go straight in and start with an application note. So this is a setup of one of our PLLs. It's the ADF 4158. ADF 4158 actually has a signal generation capability, so you can do ramping waveforms. It's meant for sweeping. It's a PLL meant for sweeping, and you can do different waveforms like triangular waveforms or FMCW even if you would choose. Now with that, the first screen that comes up is it comes up in a note section, and this describes some of the different aspects, some of the different setups. It describes the evaluation board that comes with the part. The different components that are part of this, it gives you a plots of the different components, both the PLL and the VCO that are associated with this, as well as it gives you the frequency domain performance and the time domain performance. It'll give you a schematic of what you set up, and it'll give you a report as far as the different things that it's telling you. It gives you the option to be able to adjust the reference, the VCO. If you wanted to use a different chip, let's say the performance wasn't good enough with this particular chip, you can all do that on the fly once you've set up a particular setup, and you say, okay, well, this isn't giving me what I want, so let me change the chip, or let me change the reference. It gives you the ability to change the loop filter, change the lock detect. So it allows you to do this all on the fly, to be able to make the design using one of Analog Devices' PLLs very, very easy. I'm going to go and I'm going to start a new file. And actually, I'm going to do this from the very beginning. So as you get into ADI Sim PLL, again, you have the choice to be able to create a new design. So if you're going to go in and you want to start from scratch, you can do that. We have something called the new PLL Design Wizard. As you go through, the first thing you're able to do is you're able to do a general PLL design if you'd like. You can choose your PLL if you already know which one you'd like to choose. You can choose that up front. If not, we give you an option to be able to choose it later on. Right now, I'm just going to do a general PLL design. The next thing I'm going to do is it gives you the choice to be able to either produce a range of frequencies, because a lot of times you use it to be able to get to different frequency points and you want to be able to sweep between different frequencies, or sometimes you just want one single output. And your loop filter is going to be different for those, and your different parameters, everything's going to be different based on those. So you have the choice to be able to do that. You also have the ability to choose either integer n or fractional n PLL as well. And you can choose which you can also have it choose to make sure that it actually gets you on exactly the frequencies that you would like to generate. Next, it gives you I'm sweeping, so it gives me the choice to be able to choose the minimum frequency, the maximum frequency, and the phase detector frequency, which would determine the steps that I'm able to take in between that. You also have the ability to choose whether you use an external prescaler, so you would be able to use this at a higher frequency than what you would normally be able to do by using a prescaler. We will also be able to have in this to be able to use a multiplier, so you can actually multiply up and it'll do that calculation. Next, it gives you the ability to be able to choose a part, and you can choose a specific one. We give you some key parameters. I'm going to choose today to use one of our new parts that we've just announced at the show, and actually I should have went back and chose integrated PLL with VCO, so I will just do the ADF 4150, and I'm going to choose that. I can go and I can modify this anytime. I can choose whether I want to lock detect on the output or if I want a speed up, which this part actually has the ability to have a speed up section to be able to lock quicker than what it would normally lock. You're able to choose your loop filter, and with that you can choose your loop filter topology, including various different active loop topologies. I'm just going to choose a simple one here. Next, you're able to choose whether you want to pull up a VCO from a library, whether you want to do a custom type VCO, and we have a whole range of libraries of different VCO vendors that we've included with this program. And I'm just going to choose a custom VCO and use the setup. Next, you're able to choose the frequency of your reference, and you have options to be able to either pull one out from a library or do a custom one as well, and I'm going to do a custom one. You're also able to choose the loop filter bandwidth and the phase margin. So basically you're able to choose any of the parameters that are going to affect your PLL, and once you have done that, you're able to get the frequency domain, time domain response, you're able to get a schematic, you're able to get all the key factors that you need when you're designing a PLL type circuit. Now I only have a limited amount of time, so I'm going to switch over now to our program ADI Sim RF. ADI Sim RF loads automatically into a analog devices folder, and it is a signal chain calculator. This is the way that it starts up. You start up with up to 10 stages. You can go up to 20 stages if you choose. I'm going to pull in a reference. I'm going to pull in a reference signal to start with. What I'm going to do is pull in a zero IF IQ up converter. It'll be a little bit quicker since we have a limited amount of time. You can save designs that you've done in the past. You can save components that you've done in the past. As you can see, this design actually includes a DAC. It includes filters. It includes an IQ modulator, attenuator, amplifier, a digital step attenuator, and an amplifier. So you're able to do basically everything from the DAC all the way up to the final stage PA using this. And Analog Devices has many of these components. So with that, you can choose an Analog Devices component. Let's say, for example, that instead of using the ADL 5240, you decide you want an extra amplifier stage. You can use the ADL 5243. And if you put in the frequency range that you have here, this is a digital step attenuator, so you can put in the particular gain that you choose to have. Let's say you want to put an attenuation stage of 17 dB. And it will go through and it'll pull down all the parameters straight from the data sheet. We have those loaded on a table. It'll pull it down, and you'll be able to put it into your signal chain calculator just that easy. So it's very easy to be able to pull down components that are from Analog Devices and to put them straight into your signal chain and see how that will work in your signal chain. Now, if you're not sure what device to use, we have something called the device selection, and you can pull up any of our ADCs plus any modulator, demodulator, whatever you'd like to do in that, and you can choose the best part for your application, and then you can go to your table and you can modify your signal chain for those different components. but this gives you the ability to calculate noise figure, cascaded noise figure, output power. It gives you the ability to be able to say, hey, I'm putting too much power into this amplifier, so you'd be able to put a pad before it to be able to adjust that power. It gives you all the flexibility to be able to do an initial simple signal chain calculation, making it very simple for you. Now, if you're not using an analog devices part, you do have the ability in this to be able to build a model for someone else's part. And you can build their model, get their data from their data sheet, and say, okay, well, these are the parameters, and then you can save it as a block, and you can pull it into future designs as well. So you have the ability to be very flexible as far as what you're doing and to build up the signal chain that you need for your specific application. So that's my demo today. I appreciate you joining me. I hope that you take a look at some of these software tools. They're designed to be able to make your job easier. And I hope that you come over and join us at our booth today. We are located just catty corner here. We're Analog Devices. And our booth number is 415. So thank you for your time.